Greetings everybody. This video will explain uh, how to fill out a template for online lab number 5, or number 9, not number 5, excuse me, online lab number 9, and it deals with torque. And so here's the template that the Excel file that you open, and notice you see you've got challenge 1, 2, 3, 4, 5, 6. Well, here's the link to the simulation. Let me go ahead, copy that, and then we'll paste and go. And we're going to get this balancing act, and we want to go to this is sort of more like a fun lab. We're going to go to game, and then click again, and you're going to go to level 4. And what it is see down here we have challenge 1 of 6. You're doing those six challenges. 1, 2, 3, 4, 5, 6. So in column B, see challenge 1, 2, 3, 4, 5, 6. Nothing complicated. Okay, so what is challenge 1? Well, you want to predict what will happen. And by that I mean, when over here prediction, will the system rotate clockwise or counterclockwise? You know, if the sum of the torques, if the sum of the net torques, and our pivot is the center of the bench. And and we're going to click rulers. We're going to click rulers. And now notice we have a torque created by the 40 kilogram mass, that's 0.75 meters to the left of the pivot. And then we have two torques. Torque created by the 3 kilogram at 1.25 meters, and the torque created by the 20 kilogram at the 1.5 meters. And so this system is, your prediction is either going to be a counterclockwise rotation, which is the first choice. It's going to be balanced immediately, which would be your second choice, or it's going to be a clockwise rotation, which would be your third choice. And remember, if the sum of the torques are positive, that's a counterclockwise rotation, this is counterclockwise, no rotation, clockwise. And remember, if the sum of the torques are positive, that's a counterclockwise rotation. So what we're going to do, notice we have here the 40 kilogram mass is to the left of the pivot. The 3 and the 20 are to the right of the pivot. So what you're going to do is you're going to bring up your template. And notice here, challenge 1, I have here ML1, XL1, ML2, XL2, MR1, XR1, MR2, XR2. Notice positive torque in units of a Newton meter, 0. Right now the torque is 0. Negative torque in units of a Newton meter, 0. Sum of the torques, which of course right now is 0. And then prediction. Well, remember, if the sum of the torques is positive, then your prediction would be CCW. That would be a counterclockwise rotation. Well, what are you going to do? So what I mean is ML1, that's the first mass that's to the left of the pivot. So that would be 40 kilograms. So ML1 is 40 kilograms. I'm going to enter in 40. Now XL1, that's simply the distance from ML1 to the pivot. So in this case, XL1 is 0.75 meters, 0.75, because the 40 kilogram mass, that's to the left of the pivot, that's ML1. XL1, that's the X distance from this mass to the pivot, that's 0.75 meters. So I'm going to enter in 0.75. Now notice, depending upon the simulation, you might have a second mass to the left, but in this case we don't. You see, in this case we only have one mass to the left. Now on the right side of the pivot we have two masses. We have the 3 kilogram at 1.25 and the 20 at 1.5. So now let's go to the spreadsheet, the template. So I don't have to worry about, in this case I don't have a second mass to the left. So ML2 is blank, XL2 is blank. Now let's go to the right. What is the MR1? That's the first mass to the right of the pivot. Well, that's my 3, and it's at 1.25. So I'm going to enter in, a little bit tedious. but it's 3. And I know it's at 1.25. That's what XR1 is. That's the X location of the first mass to the right of the pivot. That's 1.25. What is MR2? That's the second mass to the right of the pivot. The 20 kilograms, and the 20 is located at 1.5. So my MR2 is 20, and XR2 is located at 1.5. And notice as I enter these values, the torque columns automatically update themselves. And look at that. So now, let me pause it for a second. So notice the 3 columns for the torque, because I entered the formulas in for you. Okay, so the positive torque is, the net positive torque is 30. The net negative torque is negative 33.75. So the sum of the torques is negative 3.75 in units of a Newton meter. Remember, that's a negative torque. That is a clockwise rotation. So you type in CW. Now you go to the game, and remember clockwise. That's this guy. Remember, follow the cursor. It's rotating clockwise. And so we click that. Then you hit check. Ding, ding, ding. So we're good. Now let's go to challenge 2. Now challenge 2 is a balance me. We have to determine where to place this 12 kilogram mass such that the system balances. So notice here we have 2 masses to the left of the pivot. Let's go to the template. Now we're on challenge 2. Okay, ML1, that's the first mass that's to the left of the pivot. ML2, that's the second mass that's to the left of the pivot. XL1, that's the position of ML1. XL2 is the position of ML2. So let's go ahead and enter those values. Let's enter ML1. And you can go, it doesn't matter which one is, you call M1 and M2, just to make sure you don't confuse the coordinates. So the 3 kilogram is located at 2. So I'm going to go ahead and enter 3 kilograms. And I know it's located at 2 meters. Okay. Now let me enter the second mass. The second mass is located at, it's 20, and it's located at 0.75. See that? 20 and 0.75. So 20 and 0.75. Now watch what happens. Oh, hold on. So 0.75. Okay. Now MR, that's the mass to the right. That is the mass that you're going to use to balance the system. So go back to the simulation. And the mass on the right, see right here, it's 12 kilograms. So go ahead and enter that in. That's my MR. That's 12. Now watch what happens when I enter MR. Watch what happens to the, and this means to the right. This is what this means is this is the balance point. This is where you need to place the mass, this 12 kilogram mass. This is where you need to place it to balance. Watch when I click outside. 1.75. See, I entered the formula in for you. So in other words, I need to place the 12 kilogram mass that's to the right. I need to place it at 1.75 meters. Let me go ahead and do that. Right there, see the white dot? Okay. And then check. Ding, 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 ding. So we got it correct. So now let's go to challenge 3. And let me check the time. Yeah, we'll do. So now challenge 3, I want to know what is the mass. In other words, the unknown mass. See, this TV is the unknown mass. I want to know what is the mass of that TV. Well, let's go now to challenge 3. I'm now right here. Now XL, that's the position of the mass on the left. MR is the amount is the mass on the right. So for challenge 3, what is XL? Well, XL is the coordinate of the TV because it's to the left. Notice it's at 0.75. So I'm going to go ahead and enter that in. 0.75. Okay. MR, that's the mass on the right that I'm going to need to use to balance. the mass on the right over here, see it's 15 kilograms. Going to enter that in. Okay, 15. Now, okay, so I've entered XLMR. Now I need to physically balance. I need to balance the system. I need to move the MR, the mass that's on the right. I need to move it such that the system is balanced. So I need to take this mass here, and I need to move it somewhere so that the system is balanced. Let me put it right at 1. Okay, nope, it's not balanced. So don't hit check, because it's not balanced. So let me move it, let me put it at 0.5. And it's balanced. So in other words, my balancing point on the right, my XR balance, is 0.5 meters. That's what I mean right here. And now watch what happens to the unknown mass when I type in my balance point. What was it, 0.5? Click outside. And now the mass of the TV, the unknown mass, according to this calculation, I've entered the formula for you, the unknown mass should be 10 kilograms. Let me go up and check. Unknown mass should be 10. 10. Check. Ding, 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 ding. So we're good. All right, so that explains how to do challenges 1 through 3. To keep the video short, I'm going to do challenges 4, 5, and 6 in a separate video. So let me go ahead and save this video, and then I'll do 4, 5, and 6 in another video.